This lesson we're looking at compound interest, but we're looking at it using the simple interest method that we used yesterday. So with compound interest, you receive interest on your interest. So all your interest keeps being added into your bank account, and then you get interest on the greater amount of money, and you end up with more money in your bank account than you do if you just use simple interest. And that's something to consider when you're taking into account purchases and mortgages and things in the future. So that's one thing to know. This other statement here is also really important. There's the rule of 72, and that rule says that the number of years it takes an investment to double is approximately 72 divided by the percentage rate of the compound interest per annum. So you can work out how long, if you had $5,000 and you needed it to be $10,000 because you wanted to buy a car, you can use this rule of 72 to work out how many years it will take you to reach that goal. So we look at that over in part C of our example today. So in example 8, it says, Serena invests $2,000 at 5% per annum, interest compounded annually. Calculate the value of her investment at the end of 3 years. So to do that, we need to work out how much she'll have at the end of the first year, and then how much at the second, how much at the third. So we use our I equals P times R times N formula. So she's investing $2,000. Her interest rate is 5%, and it's just for 1 year. And if we pop that in our calculator, 2,000 times 5 over 100 times 1, we get $100. So she had $2,000. She just earned $100 interest. So the balance in her bank account is $2,100. So now we need to look at the second year. So we still use our I equals P times R times N formula, but this time she has $2,100 in her bank account. The interest rate is still 5%, and it's still just for this 1 year that we're looking at. So pop it in our calculator, and this time she earned $105 for the year. So this time in her bank, she had $2,100 at the beginning of the year, and she just added in another $105. So she has $2,205 in her bank account. Now we look at the third year. So same formula, I equals P times R times N. This time she has $2,205 in her bank account. Still 5%. We're going to pop that in our calculator. And she's earned $110.25 this year. So how much is in her bank? Well, she had $2,205 at the beginning of the year, plus she's just earned $110.25. So that is going to be $2,315.25. So for all your compound interest questions today, you need to set yourself up a table so that you can work out the interest and the balance for each of the different questions that you do. Part B says calculate the total interest that she earned. So So interest. She earned $100 the first year, plus $105 the next year, plus $110.25 the last year. So she earned, if you add that up, to $315.25. Now it says approximately how long will it take Serena's investment to double in size. So this is that rule of 72 that we're going to use. And so that means we need to say doubling time equals 72 divided by the percentage rate, and our percentage rate is 5%. So 72 divided by 5, and you get 14.4 years. It's a 4, just so we know. So 14.4 years it will take for her investment to double. So a bit time consuming, but this is how you work out compound interest using the balancing kind of method here. So have a go at exercise 103 and see how you go.